Hello everyone, I am Narmada. I am from Kongnadu College of Engineering and Technology. In this session, we will explore some knowledge about cluster system in OS. If we could imagine a world where multiple computers work together as one powerful machine. In this video, we will break down how cluster systems work, their type, advantages, and future scope, etc. And what if we could combine that power to solve complex programs faster? Let us discuss. In this slide, I have the small representation for the cl- cluster system. They are it consists of n number of systems or a certain number of finite systems. There are need to be communicate or sharing the resources between them. For this purpose, it has some storage spaces that is provided by the clusters. And then, and then we have the question in this part because why cluster are used are in OS because it improves reliability and fault tolerance and it allows scalability by adding more nodes and then it making them highly efficient for large scale computing tasks. Unlike a single computer, clusters distribute workload and across multiple nodes. It has some types. They're all high availability cluster, load balancing cluster, high performance computing clusters. First, we know about the high availability cluster. The high availability cluster that ensure continuous operation by providing downtime or the providing the failover and then it is used in banking, cloud services and enterprises applications. And then we know about the load balancing cluster. It plays a major role because it distributes workload efficiently and it is commonly used in web hosting. For this purpose, this type of cluster systems are used. Or it did computing tasks across multiple nodes or multiple computers. Then the third type is high performance cluster. This type of cluster is designed for computational intensive tasks. For example, if we do AI or scientific stimulations or that. And it uses a parallel processing for IC executions. And one more type in this cluster system there are the storage cluster. It provides massive storage solution and it is used in the cloud services or it can be accessed by the cloud services. And then uh, we had to learn about the working system or working structure of the cluster in the OS. That are the nodes share the common storage or memory pool. That is, each computer or node in the cluster is interconnected and share are used to share the resources efficiently. In this, they communicate using high-speed networking, or it uses a message passing interface for data transfer. For this purpose, it can be working together by or it can be distributing the tasks easily. If one node is failure mean the other will take over the process and ensuring the system stability and minimize the downtime or failover processes or failover issues in the systems. And then we know about the classification of clusters. The clusters are classified based on the architecture and purpose. It can be classified as dedicated, non-dedicated, homogeneous and heterogeneous. But the clusters are systems are based on the nodes, intact and share workload. They are classified as asymmetric clustering and asymmetric clustering and asymmetric clustering. First we know about the symmetric clustering. In this type of symmetric clustering, all nodes in the cluster have equal roles and share the workload. For example, in this system, in this clustering type, it has a no server that are master or served separately. All the nodes in the cluster have equal roles and share the workload. And this is no dedicated master or control as we seen in the first step. For example, load balancing cluster and high performance cluster as we seen in the type of the clustering. These are comes under the classification of symmetric clustering. And then we know about the asymmetric clustering. Uh, in the asymmetric cluster, one node that is act as a master and it can control the others. They are called as slaves. And if the master node can manage its task and assign work to the slave nodes. If the master node fail, a standby node takes over. Uh, for this purpose, the asymmetric clustering are used for the connections of interconnecting connections of nodes, and it used to share the workloads efficiently. And it has some common high availability cluster for O file over the management. And then we have we have discussed about the examples of cluster systems. They are the great example is Google search engine, right? It uses thousands of interconnected services to handle billion of searches daily. So and another example is NASA, that is NASA supercomputers, which analyze space data using the cluster. So because of this wide usage of cluster, it had be the part of in the OS. Or in be the part or in pay, it take the major role in the operating systems. And we have the another example that are the Linux clustering, which is used for the scientific application. For example, the Linux clustering, the Red Hat and OpenMI are the possibilities for using the Linux clusterings. And then we know the advantages of cluster system in OS. There are fault tolerance, performance boost, and cost efficient. In this fault tolerance, as we discussed in the distributed system, the distributed systems are the ability to tolerate the failures, or the ability to handle the failure in the system or failure in the management. So they are similar as in the cluster system. It has the ability to tolerate the fault which is happened in the analysis or in the process. So it ensures continuous operations. Or in the performance boost, faster processing through parallel executions. Because of the process, it ought to be run in the parallel execution means the performance is are in the high peak. Okay, and then the cloud are in the cost efficient. It uses multiple lower cost machine inside of supercomputer. For this, the cost efficiency is minimal in the cluster systems. And then we have to face the challenges cluster systems. They are data synchronization, network latency, and complex management. In this data synchronization, it is keeping data consistent across it, or it is keeping the data consistent across nodes, or it to be later in the delay of synchronization the data. And then the network latency. The network latencies happen when the communication delay or in the distributed environment. For this, network latency will happen. And then complex management. It requires expertise to configure and maintain, or that it requires monitoring and maintenance tools between them. So for this issue of this management, it can be seen as a complex one to us. And then it has a communication overhead because the data transfer between the node can be bottleneck, can be seen in the data synchronization as same is as same in the communication overload. So it has a data synchronization issue, network latency, complex management, and high initial cost, and communication overhead process. In this part, we will discuss about some case study in this one. That is the Google cluster system here. The Google Search, YouTube, and cloud services rely on voice managed cluster systems. We already seen in the example part itself. and it has some benefits. There are faster data intensive, high uptimes, and global scalability, and the and it has some case studies that is related on the Amazon Web Services. The AW provides cloud-based cluster solution like easy to auto scaling and elastic load balancing that ensure all or high availability and efficiency for business worldwide. For this for this type of studies, the cluster systems are used to solve the problems. And then we reach the future of cluster system in OS. They are AI driven cluster, quantum computing integration, and edge computing. As we are seen in the distributed system, is same as in the cluster because it is also the future trends of AI driven cluster, quantum computing, and edge computing. In this, it is smarter workload distribution and the quantum computing integration. It engaging the processing capability, and in edge computing, it is decentralized clustering for faster local processing. And it may revolves are to solve the problem easily by the use of quantum clusters. And then we reach the conclusion for this one. The cluster systems are the backbone of modern computing, ensuring efficiency, scalability, and fault tolerance. Whether in research, business, or daily applications like search engine, they power the digital world or want to a digital world. And it has some continuous advancements to shape the future of distributed computing. And it is the question part, right? In this question part, we have the question that is, what if we could combine their power to solve the complex problem faster? It is possible because of the cluster systems, because we connect large number of systems or now large number of clouds together to provide problems for many solutions. Thank you for all for listening to my lecture. Thank you.